Okay, here's the review for the Chapter 3 test. It's the second one that we took, Section 3.5 to 3.7. Okay, let's get right on it. It says determine the intervals of the domain over which each function is continuous. So we're talking about the domain right here, so which is the x-axis. So what we want to do is we want to think about traveling along the x-axis and decide which x point or x coordinate has a y coordinate that goes with it, that corresponds to it. So if you see this line just keeps on going down here, so every single x point is going to have a y that associates with it. Every single x has a y that associates with it. We could extend this all the way down until you get where? To right here. Alright? As soon as I get to that x point, look what happens. When I drop down to that point right there, that's going to give me no point at all. There's no point there. That's why that little circle, that little hole. And where is that point? It's at -4. It's hard to see right here, but it is -4, -3. So we're again talking about the domain or the x-axis. So at this point right here, it has no y. At -4 on the x-axis. Let me say that again, -4 on the x-axis does not have a y that associates with it or corresponds to it. So we have to leave that out. So we're talking every point from to the left of -4 and every point to the right of -4 has a y point that corresponds to it, except for -4. So it says write it in interval notation to determine the intervals, and that's what we talked about, interval notation. So what do we say? Everything from -infinity, that's as far as you can go to the left, all the way, watch, we're traveling along the x-axis. A lot of you guys are putting the y in there. It's the x. So we start from the infinity, and we keep going until we get where? To -4. So we go -infinity to -4. Those are possible values that our x-axis can be. So we put parentheses here. Remember, this determines it's open, and it's open here as well. We don't consider that point -4. Right? That's not part of our domain. So we just leave it open, and that's why this is parentheses right here. Now it's union with. Now we have to consider everything to the right. So basically, it's every single number along the x-axis except for -4. This is how we write it. So again, going from left to right, we go -infinity to -4. It's open right here. Then we jump over -4, and we go from -4 to +infinity. -4 to +infinity, and that's the intervals of the domain where it's continuous. Remember, it jumps right here. Okay, you'd actually have to pick your pencil up. If I'm going like this, I'd have to actually pick it up in order to continue it like this. All right, same thing here with number 2. We're going from the -infinity, and we're traveling along. Look, every single point over here, eventually it will get to that line, because this line would continue up like this. Every single point, I'd be able to put a y corresponding point to it. So I could keep going. Look, even when I get here, it's got a y point. If I go here, it's got a y point. If I go here, it's got a y point. All the way until you get to where? This point, again, it's kind of hard to see, but it's 3, -2, and it's an open circle. So we go all the way to right here. So everything from -infinity to +3, and everything from +3 to +infinity. It's everything except +3. Forget the -2. That doesn't come into play here. We're only talking about the domain. So we're only talking about along the x-axis. So it's basically the same type of an answer. So it's -infinity to +3. It's open. And then we also consider we'd have to jump over 3. Okay, that's why this is open. So it doesn't really count 3. It jumps over it. So it's going to be 3 to +infinity. Let's go to this one. Now look at the difference. These are all open, which means it did not include that point. Look at this right here. It comes, there's a point, they put an ordered pair, it kind of looks like the same as what we did over here, but it includes it. It's colored in, it's darkened in. So we include every single point. So every single point from a -infinity, even up to -2, that's included. So it's not open. Everything is included. From -infinity to -2, and also from -2 all the way to +infinity. All those are included. So that means all the real numbers. How do we show all the real numbers? Well, in interval notation that we learn, we go from -infinity to +infinity. That includes all the real numbers. Okay, we're going to graph a line right here, but before we graph it, we need to change it into slope-intercept form. This is linear. This is just a straight line, so you just get y by itself. So we'll start with this. Oh, let me change my pen settings. Always forget to do that. And almost there. Okay. Now, what we have to do is get y equals mx plus b. It's very easy here, so we just divide both sides, well, everything by 6. Both sides, what means everything. So we're going to get y equals 3 over 6. 3 over 6 is the same as 1 over 2x plus 18 over 6, which is 3. So this is really what we're graphing. The 3 is the y-intercept, so 1, 2, 3. Put a little dot right there at 3, and the slope is 1/2. So we're going to rise over run. So we rise 1 and we run 2. So rise 1, run 2, and it's right there. And if we, let me see if I can draw a straight line like this, and we just connect them, and let me just, it just makes it look a little neater. Alright, there we go. And there's our graph. It's simple as that. It's linear, y-intercept, slope, and there's your graph. Let's go to this one. This is a little bit different. This is absolute value. Those bars right there mean absolute value. It's kind of already in, I guess you can call it slope-intercept, but it's in the form that we want because it's y equals. Now remember what's happening here. What does the absolute value look like normally? It looks like a v. Well, what's happening to that v? Well, 3 things are changing that v. First of all, it's going to change the, it's going to move to the left 4 places, and that indicates to the left 4 places. If you're not sure why it's to the left, you can go back and look at your notes on that section. We've talked about that quite a bit. And this right here moves it up and down, and that moves it down. So this goes to the left 4 places, and this moves it down 4 places. This kind of changes, I don't think we really call it the slope, but you can think of it as the slope. It changes how steep it is. Alright, we'll talk about that in just a second. So remember, it looks like a V. So it's going to move, so the vertex of that V normally would be right here, but we're going to move it to the left 4 and down 4. So 1, 2, 3, 4 to the left, and 1, 2, 3, 4 down. So your point's going to be right here. Now, what is that 2 doing for us? Normally, we would just go up 1 to the right 1 and draw our V this way, draw our V this way. Alright, let me put a couple more points in here. But this time, instead of going up 1 to the right 1, we're going to go up 2 and to the right 1 because it's 2 over 1. So it's kind of like a slope, I guess. So it's 1, 2 over 1. I'm just kind of eyeballing it right here. And then 1, 2 over 1 this way. And now you can connect them. So draw a straight line like this, draw a straight line like this, connecting them, and there you go. And there's your absolute value graph.